Hello everyone, today I'm making the other movie in order to cover the explanation of chapter 6. Yes, chapter 6 should be the last chapter for our course syllabus or our course term. And yes, we already learned so far from previous chapter, especially concept of probability. So chapter 6 still in the probability, but we just continue from chapter 5. Okay, this is the title of chapter 6. Discrete probability distributions. Discrete probability distributions. Okay, this is the title of chapter 6. This is the goals or the objectives of this chapter. When you have completed this chapter, you will be able to 1. Define the term probability distribution. So when you finished or when you have completed this chapter, you expect that you can give definition. What is probability distribution? That's why you can give definition or you can define the term probability distribution, and you will be able to identify the characteristics of a probability distribution. Okay, so the first point you need after completing this chapter, you can give definition the probability distribution, and you can identify, you can recognize the characteristics of a probability distribution. Second, you will be able to distinguish, try to understand clearly the difference. Okay, distinguish between a discrete random variable and a continuous random variable. So you need to be clear, what does it mean discrete random variable, what does it mean continuous random variable. Okay, so we already learned from chapter 1 about variable. What does it mean variable? Yes, from chapter 1, variable refer to something that we don't know and we try to know. Why we don't know? Because the value of this thing always change time to time, condition to condition. That's why we don't know for sure. That's why we try to know the value of variable. So yes, from chapter 1 I also mentioned variable came from the word vary that means change. So variable is changeable, something that always change. Okay, so something that we try to understand and always change their value, their condition, or their shape, divided by 2. Discrete variable or discrete random variable, continuous or continuous random variable. 3. You will be able to compute or calculate the mean of a probability distribution. Yes, we already learned so far in chapter 3 central tendency. We have to compute mean, we have average mean, we have arithmetic mean, we have weighted mean, we have geometric mean. But in this case is arithmetic mean. Okay, so chapter 3 point 3, you will be able to compute the mean of a probability distribution. Point 4, you will be able to calculate the variance and standard deviation of a probability distribution. The variance and the standard deviation we already learned from chapter 3 but part 2, mean chapter 3 part 1, measure central tendency, variance, standard deviation, part 2, measure spread of data. Okay, that's why mean, standard deviation, variance still coming to see us again in this chapter. 5. you will be able to describe, to say something, and to compute the probabilities for a binomial distribution. Okay, you'll be able to describe and compute or calculate the probabilities for a binomial distribution. 6. You will be able to describe and to compute the probabilities for a hypergeometric distribution. This is binomial distribution. This one for a hypergeometric distribution. 7. You will be able to describe and compute the probabilities for a Poisson distribution. So 5, 6, 7, you have to compute and you have to describe and compute probabilities for binomial distribution, for hypergeometric distribution, for a Poisson distribution. Okay, we have 7 points for this chapter in order to learn or to run for this chapter. Okay, so we learned chapter 2, we learned chapter 3 so far. Chapter 2 and 3 were on descriptive statistics. It means that we use descriptive statistics to study, to learn chapter 2 and chapter 3. That focus on summarizing the data, measuring the data, or maybe describing the data. So for descriptive statistics, we learn some techniques. Those techniques can be used in order to identify or to understand central tendency of data by calculating, by examining the mean or median or mode, mean, median or mode, or mean, median and mode together. The other one, spread. In order to describe the data, we also use the other technique, not only central tendency but also spread the data by examining the range, standard deviation, variance, something like this. However, the real chapter 5 focused on inferential statistics. Inferential statistics is a technique or is a type of statistic that we use in order to infer the population based on sample. Infer, that means to conclude, to judge, to evaluate, or to say something about a population, but based on a sample result. It is also stated a probability is a value between 0 and 1 inclusive. Okay, it is also stated the probabilities of something that we study must, the values of probability of something that we study must between 0 and 1, 0 to 1, not 0 and 1, 0 to 1 inclusive. And how probabilities can be combined, and how probability can be calculated, can be combined. Okay, how about this chapter? This chapter will focus on probability distributions. That's why before you understand what does it mean probability distribution, you need to understand probability. Okay, you need to understand probability from chapter 5, and you need to understand distribution from which chapter? Chapter 2. Okay, remember that we have qualitative data set and we have quantitative data set. Qualitative data set, we have frequency table. Quantitative data set, we have frequency distribution table. Okay, that's why this is from chapter 5, this is from chapter 2. So chapter 6 is about probability distributions. Okay, question: what is a probability distribution. What is the probability distribution? A probability distribution is a listing of all the outcomes of an experiment. Is the listing of all outcomes of an experiment and the probabilities associated with each outcomes. Okay. So what does it mean, probability distribution? Probability distribution is a listing of all. What does it mean, listing? 1, 2, 3, 4, 5, 6. You know listing, right? A list student 1, 2, 3, 4, 5. That's why this is probability distribution is a listing of all outcomes of an experiment that we're doing together with probability associated with each outcomes. Okay, that's why if we have list 1, 2, 3, 4, that's why this is outcome, and we also have probability. Outcome 1 have probabilities of 1. Outcome 2 have probabilities of outcome 2. Outcome 3 has probabilities of outcome 3. Outcome 4 have probabilities of outcome 4. Okay, that's why this is we call probability distribution. Is a listing. This is a listing 1, 2, 3. It is the outcome. This is probabilities of outcome. I can say X is outcome. Outcome 1, 2, 3 you list, and then every outcome of listing outcome has its own probability. That's why this is we call probability distribution. So again, probability distribution is a listing of all outcome of one experiment together with the probability associated with each outcome. Okay, this is just like a table of probability distribution. Probability distribution gives the entire range of values that can occur based on experiment. Okay, so one experiment give us different possible outcomes. That's why when you look at probability distribution, it gives you an entire range of values that occur based on one experiment. It is similar to a relative frequency distribution. It is similar. So frequency distribution similar to a relative frequency distribution, but it is used to describe how likely some future event. So relative frequency distribution in chapter 2, we do it based on the information or data from the past time. Okay, for the past time. But in this case, it's similar to probability distribution, it's similar to relative frequency distribution, but probability distribution is used to describe, is used to predict, is used to see something in the future, to see events will happen in future. How future events will be like, look like, something like this. Okay, so it's similar to probability distribution, similar to relative frequency, but will be used differently. Okay, we will use differently. Okay, so maybe you will, some of you maybe not clear or not clear in terms of what does it mean, relative frequency distribution, that we learned from chapter 2. So I just raise 2 tables for you. Okay, so this is remember that one, this is from chapter 2. This is a relative frequency table that used qualitative data. This is qualitative data. Okay, when we have only 2 columns, we call this column as frequency table. If you put one more column, this is called relative frequency. So probability distribution similar meaning to this one. This is relative frequency distribution by using qualitative data set. How about probability? How about relative frequency distribution by using quantitative data set? Okay, this one. Okay, so the difference is, you can see the difference is, this is qualitative. Qualitative is not number, quantitative is number. The difference is here. This is qualitative, something that we study, not number, non-numeric. But quantitative, something that we study is number. But this is the same thing. This is the same thing. This is a frequency, this is a relative frequency. Okay, so this is, I just review 2 tables from chapter 2 regarding to relative frequency distribution. How can we generate, how can we construct, how can we make a probability distribution? How can we generate, how can we construct, how can we develop, how can we make a probability distribution? In order to make, in order to develop, in order to construct a probability distribution, unless you have something to study. Okay, now for example, 3 tosses of a coin. Suppose that you have a coin, but you test this coin 3 times. Tossing a coin 3 times. So have 1 coin and you do it, or you toss this coin for 3 times. Okay, so 3 tosses of a coin. This is the first tossing. So the first tossing result will be, because coin has only 2 faces, so I label one face as H. H stands for head, the other stands for tail. That's why H head, T tail. So when you have a coin and you toss 1 time, toss like this one, the possible result could be 2. Could be H or T. This is possible result. But when you toss, actually, the actual result only 1 time, only 1 coming. Among 2 possible result, among 2 possible outcome, only 1 coming. It could be H or it could be tail. If H coming, tail cannot. That's why, remember that mutually exclusive outcome or mutually exclusive event. That's why the event or the outcome H or tail are H and tail are mutually exclusive outcome, because only one at one condition at one time, only 1 coming, cannot both of them coming. This is the first toss. Second toss, take the same coin but you do it the same second time, so it could be H or it could be T coming. Take the same coin but you toss for the third time, it could be H or it could be T coming. That's why This is we call experiments. Tossing a coin 3 times is our experiments. Okay, so the possible results from 3 tosses of a coin are 0 heads. What does it mean 0 heads? It means that the actual outcome, the first is tail, the actual outcome of second is tail, the actual outcome of the third toss is also tail. That's why all actual outcome are tail. That's why no heads. Or it could 1 head coming, or it could 2 heads coming, or it could 3 heads coming. 3 head coming, it could be the first one head, second one also head, the third one also head. Okay, so when we toss a coin, the same coin for 3 times, the possible outcomes or the possible results could be 0 head, 1 head, 2 heads, or 3 heads. Question. What is the probability distribution for the number of heads? So we want to find head. What is probabilities of heads coming? Okay, numbers of heads coming. That's why those can be make a table like this one. There are 8 outcomes. There are 8 possible outcomes are. This is possible result. For the first one, the first toss tail, second toss tail, the third toss tail. That's why no head, 0 head. Second one, the first tail, second tail, but the third edge head. That's why 1 head coming. The third one could be the first toss tail, the second edge, the third tail. That's why 1 head coming. The fourth time, the first possible result could be the first toss tail coming, the second toss head coming, the third toss head coming. That's why 2 heads. The other possible outcome, the 5th possible outcome, it could be the first one head, second one tail, third one tail. That's why only 1 head. That's why this is all possible outcome. So if you have one coin, and one coin has 2 sides, 2 possible outcome. If you have one coin, and one coin have 2 possible outcome when you do tossing, and you toss 3 times, so I can say that 2 outcome with 3 times tossing. 8 possible outcome. Okay, 8 possible outcome. For example, if you have a die, let's say this is a die. Yes, this is number 1, this is number 4, this is number 3. Okay, it have died, and you toss it 3 times again, the same as a coin. So how many possible outcome? Okay, if I have a coin, I toss the same coin, only 1 coin. I have 1 coin, I toss this coin for 3 times, I will have 8 possible outcome. For example, if I have a die, and I toss, or I roll it, not toss. Because you can toss it or you can roll it. Roll make me round on the table, on the floor. 3 times. So how many possible outcome could be? Okay. Yes. So this is all possible outcome. There are 8 possible outcome. Among 8 possible outcomes, we are interested or we focus only head. That's why we care only head, no tail. The outcome of 0 head coming is only 1. Not 0, this is 0 head, but 1 outcome. Okay, 1 outcome. The outcomes of 1 head coming or 1 head occurs 3 times. 1, 2, 3. Okay. The outcome of 2 heads occurs 3 times. 1, 2, 3. The outcome of 3 heads occur only 1 time. 1. Don't confuse this is 3. This is 3 heads, but only 1 possible. This is possible, this is a head. Okay, so only 1. Okay, so this is all possible outcome of 1 coin with 3 times tossing. All possible outcome, but this is not a probability distribution yet. Okay, the probability distribution for the number of heads here. That's why we list, because we are interested or we focus on head. So 1 possible outcome could be 0 head, 1 head, 2 head, 3 heads. Okay. So this is probability. This is outcome associated with probability. That's why this is we call probability distribution. Remember that I showed you from chapter 2. We have quantitative relative frequency distribution. We have qualitative relative frequency distribution. In terms of this is relative frequency distribution, because we take outcome. We take actual outcome divided by total frequency or total outcome. Okay, so this is a table, a probability distribution table. We want to show in terms of graph. Okay, this is bar chart. That's why this probability we put as a vertical and outcome we put on horizontal. That's why like this one. So we can see that 1 head possible outcome and 2 heads possible outcome have the same probability. 0 head possible outcome, 3 head possible outcome has the same probability. Okay, so again, this is probability distribution table. This is chart of probability distribution or bar chart of probability distribution. So what does it mean, probability distribution? Okay, characteristics of a probability distribution. So after we understood what does it mean, probability distribution, now we need to understand, or you need to identify, or you need to recognize the characteristics of probability distribution. If you cannot recognize, cannot identify the characteristics of a probability distribution, you cannot use probability distribution correctly. Okay, so you need to understand this one, you need to remember this one in order to use probability distribution correctly. First one, the probability of a particular outcome is between 0 to 1 inclusive. Okay, between 0 to 1 inclusive. That means 0 including, 1 also including. So this is a symbol. So probability of x must be between 0 to 1. That's why probability of x sometimes could be equal to 0, sometimes could be equal to 1, or sometimes between 0 to 1 or 0 and 1. 2. Each outcome, each result is mutually exclusive event. Maybe I talked already of previous one when we toss a coin. If head coming, tail cannot come. If tail coming, head cannot come. That's why head and tail of one coin tossing are mutually exclusive events. Because when one coming, the other one cannot come. That's why this is mutually exclusive event. So we learned already from chapter 2. 3. The list of all outcomes, the list of all outcome or the list of all possible outcomes is exhaustive. Exhaustive, that means when we add all mutually exclusive events together must be equal to 1. Okay, exhaustive. So the sum of the probabilities of the various events is equal to 1. Okay, it's equal to 1. That's why the probabilities of any outcomes from the same experiment must be equal to 1 when we add them together. Okay, so in order to use a probability distribution correctly, you need to remember these 3 points, these 3 characteristics. Okay, 1, maybe not really a new characteristic for you, because we learned from previous chapter for this one, and this one we learned from chapter 2, and we learned from chapter 2. But chapter 2 is about number. Okay, it's about number, or it's about non-number in terms of qualitative data, or number in terms of quantitative data. But this is in terms of chance, in terms of likelihood, or in terms of probability. Okay, you can go to your textbook on page 189, cell review 6.1. This one, 169, cell review 6.1. Okay. The possible outcomes of an experiment involving the roll of a six-sided die are 1 spot, 2 spot, 3 spot. Okay, so what does it mean 1 spot? For example, this is a die. Sorry, this is die. This is 1 spot. This is 4 spot. This is 3 spot. Okay, that's why this is 1 spot, 2 spot, 3 spot together up to 6. Okay, up to 6. A. Develop a probability distribution for the number of possible spots. B. Portrait display, show the probability distribution in terms of graphic. Graphic is bar chart that I just show you. C. What is the sum of probabilities? Okay, this is your practice. If you can do it correctly, it means you understood the point that I'm talking, I was talking, or I was explaining you so far. Okay, now going to variables. Okay, so maybe I also explained from previous chapter, especially chapter 1, what does it mean variables, and the objectives of this I also mentioned about variable. Variable come from the word vary that means change. So variable that means changeable, something always change in terms of value, in terms of shape, in terms of appearance, okay, or condition. Random, what does it mean random? Random is something that will happen based not our intention, based not our plan. Okay, so it's random. It's something that happens based on chance, based on chance, or based on a condition that we cannot control, we cannot manage, or we cannot direct it. That's why random is something happen by chance, we cannot control, we cannot manage. That's why random variables refer to variable that we cannot manage, we cannot control. Because we cannot manage, because we cannot control, that's why we try to understand. We try to identify them. In any experiment or event, the outcomes occur randomly. In any experiment or event, the outcomes occur randomly. Maybe you go to die tossing. If you have one coin, okay, you have one coin, and there are two faces or two sides. Two faces or two sides, it depends on what you say. One is, let's say, head. One is head and one is tail. Okay, so when you toss one time tossing, one toss, one tossing, are you sure that head always coming? Are you 100% sure that head will coming? No tail? Or are you sure that tail coming or tail occur, no head? Okay, we cannot do it. We cannot be sure that always head will coming, exactly head coming, no tail. Who can be sure for that one? No. Okay, so that's why when you toss one coin, head or tail will come. Head or tail, not head and tail. Head or tail will come, but we are not sure whether head or tail coming. That's why head and tail are random outcome. We don't know. When I toss it, I want to see head coming. Maybe you can ask me, or I ask myself, am I sure when I tossed it, head must coming? Not sure. Okay, not sure. This is if natural tossing. But if you do something in terms with coin, okay, especially when you go to do gambling, maybe they have tricky for you. They have trick for you. The coin, when they toss, they want to get head coming. They will take head coming. Head always coming if they want head coming, because this coin not naturally. This coin they put something inside, or they will change something of the coin. This coin not naturally. This coin will be change something. That's why head and coming or tail coming, it depends on what they want. They can change. They can make a tricky. But if this coin naturally and you toast it without any tricky methods, that's why the outcome will be randomly. We are not sure whether head or tail coming. That's why when you toss a coin one time, a outcome must be coming, but we are not sure whether head coming or tail coming. That's why head or tail we call random outcome of one coin tossing. Okay, so in any experiment or event, outcomes occur randomly. We cannot control, we cannot manage, we cannot say exactly this must be coming. No, we cannot do it. Okay, some experiments result in quantitative outcomes. Yes, some experiments result in quantitative outcomes, while the other result in qualitative outcomes. So it depends on nature of your experiments. Okay, it depends on nature of your experiments. For example, you have coin. There's no number on the coin face or no coin side. You put only head or tail. That's why this is qualitative outcome, head or tail. Okay. Random variable is a numeric value that randomly determined by the outcome of an experiment. Is a value that randomly occurred by the outcome of one experiment. Okay, these numeric values can assume different values over time, from time to time, and from condition to condition, from situation to situation. It means that its value is subject to change due to the chance. Okay, so the values of random variable subject to the change, to change due to or because of the times, condition, situation. Okay, this is again possible outcome for 3 coin toss. Okay, 3 coin tosses. It could be this one or it could be the other one. Okay, that's why random variable is the numeric value that randomly randomly occurring by outcome of an experience. We're not sure, we cannot manage, we cannot control it, okay, because it is random or randomly. A random variable can be either discrete or continuous random variables. Now we have discrete and we have continuous. Okay, this is random variables. Discrete probability, if it is a discrete random variable, we will study probability distribution of a discrete random variable. If it is a continuous random variables, we will study probability distribution of a continuous random variable. So discrete in this chapter, chapter 6, continuous next chapter, chapter 7. This is discrete. You can see one outcome, one outcome, one outcome, one outcome, one outcome, not connected to each other, not linked to each other. This is discrete. How about continuous? You can connect to each other. It's a line. Okay, this is no line. This is a dot, dot, dot. Okay, for example, I can say this is dot, 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 one, dot. Bigger one, yes, bigger one, dot, dot, dot. Oh no. Okay, no, bigger. If bigger, it should be linked together. Okay, so maybe it's better here. Okay, it's just a dot, no, just a dot here, no connect to each other. That's why one outcome to next outcome, no connection, because it's discrete. But in terms of value, for example, I can say that 2, 3, 4, 100, 101, 1010, 1 million, 1 million point 2. This is discrete. But for continuous, in terms of number, for example, 1.356789001 2 something continue. I don't know when is it ending. We don't know for sure ending. That's why this is called continuous. Okay, this is discrete, this is continuous. For example, 1 over 3, 0.33333. I don't know how many 3. We don't know. Okay, this is discrete, this is continuous in terms of number. So in terms of our random variables, also divided by 2, discrete variable and continuous variables. Because a discrete variable, the value happen randomly, we don't know for sure. That's why we call discrete variable a random variable, continuous random variable. Okay, discrete random variable. Maybe I already explained the meaning of random variable previous slide. Now we just add discrete. Discrete random variable is a variable that can assume only certain clearly separated values of some item of interest. Maybe when you read this one, it's a little bit hard to understand. Okay, it's a little bit hard to understand. But remember that just they say this one only certain clearly separate value. Separate, that means not linked together. Okay, linked together. A random variable is a discrete if it has a finite or countable number possible outcomes that can be listed. For example, okay, only 0, 2, 4, 6, 8, 10. So the outcome could be 0 outcome, 2 outcome, 4 outcome, 6 outcome, 8 outcome, 10 outcome. Okay, so 0 is one outcome, 2 is the other one outcome, 4 is the other one outcome, 6 is the other one outcome, 8 is the other one outcome, 10 is the other one outcome. So we can count 1, 2, 3, 4, 5, 6 outcomes or 6 possible outcomes. Finite, that means we can set, we know exactly. So from 0 to 2 we know exactly, from 2 to 4 we know exactly, from 4 to 6 we know exactly, from 6 to 8 we know exactly, from 8 to 10 we know exactly. That's why this is called discrete. 0, 2, 4, 6, 8, 10 are discrete variables. How about continuous? Continuous random variables refer to any variable that can assume an infinite numbers of value within a given range. It is usually the result of some types of measurement. A random variable is continuous if it has an uncountable number of possible outcomes, represented by intervals of interval 1 on a number line. For example, this one you can see from 0 to 2 we cannot count how many numbers. Why? How many number? For example, I just gave this is exactly 0. After that we have 0.000000001. After that we have 0.0000002. So from 0 to 2 we cannot count how many numbers within this range. Okay, within this range from 0 to 2 we cannot count the number because a lot uncountable number. And from 2 to 4 this is exactly 2, but after that 2.0000001, 2.0000000, I don't know how many 0, 2. That's why this is how many number that you can count from 2 to 4 cannot be counted. That's why we call uncountable numbers or possible outcomes, represented by interval. This is interval on a number line. This is number line. Okay, this is a continuous. Okay, so I can based on this I can say, maybe I can give example based on this kit. Maybe I ask you how many brother sister that you have. Brother sister in terms of sibling. How many sibling that you have? Okay, how many sibling that you have? Some student they are a single child. That's why 0 sibling. Some student they are two children. Family with 2 children. One is him or her, and the other one his brother or his sister. That's why 2. Okay, how many siblings you have? Maybe 3, 4, 5, 6, 7. Or how many motorbike that your house has? your family has. Some household or some family has 2 motorbikes, have 1 motorbike, or some family have no motorbike but they have car. That's why number of sibling, number of brother sister that you have, this is we call discrete random variable. Because from student to student, number of brother sister change. But I'm not sure. I don't know in advance. There were Mr. A, for example, I'm Mr. A. For example, I'm Mr. A. I don't know Mr. A before. And moreover, I don't know how many brother sister that Mr. A has. Okay, that's why the number of brother sister of Mr. Brother and sister of Mr. A, this is we call random, because we don't know for sure. And brother sister is variable, and because of people cannot 1/2 people, 2.5 people, that's why this is we call discrete. Okay, so I can say that number of people, number of classes, number of motorbikes, number of cars, number of trees that you grow, they are discrete random variable, because from one household to one family to one family, one city to one city have different numbers of car, number of motorbike. One family to one family have different numbers of member, and one family to family they grow different number of trees. That's why this is we call discrete random variable. Okay, how about continuous? Okay, maybe ask one way is how much money in your bank account, not in your pocket, because yes, the money in your pocket is discrete. Okay, it is discrete, but money in your bank account is not discrete, because beside for example, if you have $100 point something here, this is continuous. We don't know for sure. That's why continuous. That's why amount of money in your bank account, this is continuous. But amount of money in your pocket, in your wallet, this is discrete. Because if you see 100 real, 1,000 real, 1,000 real. But if you put 10,000 real in bank account, next month when you check it, not 10,000 real, because plus interest rate is not discrete, it's continuous. Okay, that's why this is discrete. For example, the other one, how far from your house to school? If you are closer, you say that maybe only 100 meters to your school. Are you sure that exactly 100 meters? No. Maybe you can, okay, the distance from my house to school is only 1 kilometer. Are you sure exactly 1 kilometer? No. Okay, that's why this is we call continuous random variable. Why? Because it depends on distance. One student may be far, one student may be closer to school, one student may be a little bit further. That's why the distance change from student to student. So that's why this is we call continuous random variable. Okay, this is continuous random variable. And the other one, this is also note your age. Okay, I ask you your age, and then you need to answer me. I am not answering for you. How old are you? Okay, how old are you? And what is your answer? What is your answer? Whether your answer is discrete random variable or continuous random variable. Okay, I ask you how old are you? You need to answer your age, and I ask, is your age just answer a discrete random variable or continuous random variable? Okay, answer me. I'm waiting to hear your answer in terms of this one. How old are you? Is your age that you answered? How old are you? If your age is your answer to respond how old are you, is discrete or continuous random variable? Okay, yes, I'm waiting to hear to see. Okay, maybe I stop by now, and then let you to watch and try to understand very clear. If you are not clear, yes, we can contact each other.